California is rattling from the Cascadia earthquakes. We had a magnitude 4.7 quake hours after a 3.7 and just a few days after the 5.2, and we're having smaller quakes as well. These were the quakes that were bigger than 2.5 magnitude. Of course, we've had smaller ones in the area. And this is the Cascadia arc at the Golet plate. We'll see it on the maps. There are volcanoes there. One of them is north of that. In the Juan de Fuca plate, the axial seamount, which is an undersea volcano. The seamount is a submarine volcano on the Juan de Fuca plate on the ridge. It's west of Cannon Beach, Oregon. The seamount is the youngest volcano and current eruptive center of the Cobb-Eckelberg seamount, located at the center of geological hotspot and the mid-ocean ridge. It's geologically complex, but we have other recent underwater eruptions as well. They've found that that are closer to the coast of California. Of course, it's very difficult for them to see what's going on there. Now, the Cascadia, unlike most tectonic plates, the Golet plate experiences significant intraplate deformation inside its boundaries. The subducting Golet plate is connected with the volcanoes in Northern California, namely Mount Shasta and Lassen Peak. And Lassen Peak last erupted 1914 to 1917. The Golet plate is one of the northern remnants of the Farallon plate. That's the ancient plate that is found subducting under the west coast of North America. It's even said that it's the plate that is lodged pointing inwards towards the mantle, and that's what is causing the mantle plume to be pushed, the plume that's coming in from Baja, California, the plume that feeds the area of the California high-threat volcanoes, is also pushed towards the east, going up towards Utah and Yellowstone. And we've had various quakes in Utah lately, and those quakes are still ongoing. That is an area of 8 volcanoes. We'll see that too. 8 volcanoes in Utah. And that is the exact line, the trail that the mantle plume takes to go to Yellowstone. It's the pushing of the Farallon plate, they say, that is causing that division and the mantle plume going and feeding into Yellowstone. That's the Farallon plate. And its name for the Farallon Islands, which are located just west of San Francisco in California. Over time, the central part of that was completely subducted under the southwestern part of the North American plate. And the remains of that are the Juan de Fuca, the Explorer, and the Golet plate, subducting under North America of the North American plate, the Cocos plate under Central America, and the Nazca plate subducting under the South American plate. The Farallon plate is also responsible for transporting old island arcs and various fragments of continental crustal material rifted off from other distant plates and accreting to the North American plate. And these fragments from elsewhere are called terranes, or sometimes exotic terranes. Much of North America is composed of these accreted terranes. Now, let's go and look at the maps so that we can have an idea of what's going on in that area. On plate that we were talking about 30 million years ago, and 20 million years ago, 10 million years ago, 5 million years ago, and the present day. As you can see, it's pushing in continually. Okay, that's the Juan de Fuca right there. And this is where we had our quakes, as you can see. Let's pull out a little bit so you can see a little bit further. Okay. Now, we did have a Lake Tahoe quake that shook the whole area, and we saw the lines, the shake lines going to reaching Long Valley and reaching Lassen Peak in one of my previous videos the other day. Okay, and this is, of course, the pulling out again so you can see the Baja area. Okay, Baja right here. And the western branch of that mantle plume goes to the actually the Walker Lane fault system right here, which has all these high threat volcanoes. This is San Andreas fault right here. The Hayward fault right here meeting at Salinas. And this is the Garlic fault. This is Ridgecrest right here. And this is the Walker Lane fault system, pushing into the Cascadia arc this way. Okay, you can see the part of it going this way. That's the Juan de Fuca plate, the Gorda plate. And this is where we've had quite a few Gorda Escarpment, Mendocino Ridge. We've had a lot of quakes here lately. And they are now boarding. They used to be 3.5, then the 4, now they're boarding at 5, as you can see. They're getting bigger. Okay, so we have the Lake Tahoe. And pulling out so we could see Yellowstone right there. A little bit more. Okay, sorry. So this is the origination of the mantle plume. Of course, the whole thing here is full of magma, going all the way down to the volcanoes of the west coast, Mexico, Guatemala. Okay, now we have, this is the area of Utah. Okay, and going up into the area feeding Yellowstone right here. And this is where we have our swarms, Yellowstone swarms. Okay, because of the fact that when you have all these quakes, of course you're going to have swarms here because they're pretty big. Now, going back to our quakes. Okay, I put all the little ones. Let's take the little ones out so we can have a better idea of what we're looking at. This is Utah right here. Okay, this is just today's quake 3.9. But these are the quakes that we're talking about. The 3.7 took place before the 4.8. Okay, one person reported that, but this is reported by, let's put it up for you, many hundreds, if I remember correctly. Okay, 448 reported to USGS that they felt it. And the shake map, let's go to this is Eureka, okay. And, okay. Unfortunately, they stop at some place. They stop at a block here. And the thing is that people felt it, you know, it must have been thousands that felt it because 448 reported it to USGS. Okay. And this is the area that we pinned right here. And Lake Tahoe had the bigger quake a little while before, right here. Let's go back. Lake Tahoe, where is it? This one here. Sorry. Okay. That's a Lake Tahoe area. Okay, right here. Not the 3.2. Anyway, we did a video on that. And we saw the shaking of that. There we go, 4.5. And that took up areas. You can see how much shaking it was. Yes. And it was reported by almost 7,000 people to the USGS. That was 4.5, so that was not small. Okay, so this is Mono Lake. This is Long Valley Caldera right there. You can see again the the vibrations are stopping at a block. Okay, that's stopping at a block, but if you extrapolate them, of course, it's below Mono Lake, where we have Long Valley Caldera. Okay, and Lassen Peak up there. It's basically equidistance from Long Valley to Lassen Peak. And in miles, it's about, what, 120 miles or something, 110 and 130, yes. Okay, so that's Lassen Peak, just across from basically the quake that we had again today. Okay, right there. Lassen Peak, right there. Okay. It shook Lassen Peak, as you could see. It shook up. It's not that far, obviously. All right. So, going back to our Petrolia quake. Our Petrolia quake. Felt by almost 500 reported. And this is the one that was a few days before, on the 18th. That was 5.3, as we saw, reported by almost 2,000 feeling it. And it shook, as you can see, the whole area. Again, they stopped the block. They stopped the block. But obviously, it was... it must have shaken Lassen Peak as well. Anyway, Lassen Peak is a very high threat volcano, just like Long Valley Caldera, which is a supervolcano. And the thing with the supervolcanoes is because of the fact that their caldera is bigger, there's more of a chance of cracking the roof of the caldera, of the magma chamber. Okay. Here we are at the Cascadia zone. Here we are at today's these past days' earthquakes. And unfortunately, I forgot to show you the Canadian map. What's happening in Canada. Because just because we don't have them on the map, it doesn't mean that they're not taking place. And here we are. You can see these are the past days' earthquakes, actually. Okay, this is 2 days ago, 2.5. You can see, and these are today's quakes even on the East Coast. Okay, the 22nd, 23rd. Okay, 2.5, but you can see there's quite a lot of activity. And here, west and east. But going to the Cascadia subduction zone, they've given us the profiles. Let's take the Oregon profile. This is what's happening with the subduction here. And this is the Vancouver subduction. The Vancouver subduction is up here near the axial seamount we have here. Okay? So the two contrasting models of the lithospheric structure, the subduction of the Juan de Fuca plate between North America changes markedly along the length of the subduction zone, notably in the angle of subduction, as we see here. The angle. This one goes in more, this one goes down more. Oregon. The angle of subduction, distribution of earthquakes, volcanism, geologic seismic structure of the upper plate, regional horizontal stresses, and to investigate these characteristics we conducted detailed density modeling experiment of the crust and mantle along the two transects across the Cascadia, the Vancouver and the Oregon. One crosses Vancouver Island, that's where we have a lot of earthquakes, lots of earthquakes. Okay, and we see them better on we even had one in Seattle the other day. Okay, 3.2, and let's see how many people felt that. Yeah, they reported 176 reported. But you can see them better on, as we said, the Cascadia earthquakes on. See, they don't have it, they don't map them for Canada, but they're there. There they go, right there. So it's very active. So one crosses Vancouver Island and the Canadian margin, the other crosses the margin of central Oregon. There we go. Both density models were constructed independently to a depth of about 50 kilometers. Depth 50 kilometers. There we go. 50 kilometers. But as you can see, there it's going down to 200 and 150 to 200. Okay. We gathered all possible geologic, geophysical, borehole data. Our results confirmed that the outgoing slab of the Canadian subduction zone dips significantly deeper beneath Oregon. It's deeper under Oregon, right there, you can see. Beneath Oregon, then beneath Vancouver Island, lending support to the idea that the Juan de Fuca plate is segmented from north to south. So it's two different, it's segmented, it's in pieces. Amazing. It's in pieces. Where are we? Okay, sorry about that. In addition, our gravity models indicate that the mantle wedged beneath Western Oregon, here, Western Oregon, below the Western Cascades is lighter than the mantle beneath the Canadian continent. It's lighter. This low density agrees with the low mantle velocities observed in the mantle and the present-day extension regime of the Pacific Northwest. A gravity low at the deformation front of the Oregon mantle, absent along Vancouver margin, can be explained by the different bathymetry, the depth of the two regions, and by the depth to the top of the subduction Juan de Fuca plate. Of the accretionary prisms along these profiles were modeled with equal densities. A density inhomogeneity in the lower part of the models would be necessary, thus that the density of the accretionary prism for the Vancouver profile must be about 0.1 to 0.2 grams per square centimeter, greater than for Oregon. A density difference within the accretionary prism also agrees with other data. We note that the volume of accreted sediments is about twice as large along the Vancouver profile than along the origin profile, and the prism reaches a greater depth, 20 kilometers compared to 12 kilometers for the Oregon profile. This implies that the sediments within the accretionary prism at Vancouver are at a higher metamorphic grade and therefore have higher densities. We find that a substantial part of the coastal gravity maximum for both lines is caused by increasing density with depth in the subduction plate. In the proposed model, the maximum possible density of the slab was used to satisfy constraints for the average density of the near coastal crust for both profiles. If a density increase with depth is not introduced, very high densities would be required for the near surface coastal and continental coastal blocks. Anyway, you can see that they're different, and what we get out of this is that is probably in pieces, because one is more dense and one is less dense. More dense, I guess that's why it's going down a little bit slower, okay, or not that fast, whereas this one in Oregon, which is less dense, is going down much further down into the mantle. Okay. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.